Yeah. Now those are your attitude things. Now there are going to be strategies that we're going to see, uh, and I'll show them through some different examples. So first example, let's say we want to simplify uh, cosine x minus cosine x times sine squared x. Now some of you might notice right away, what can we do with this? Well, both terms have a cosine x, so we can factor out a cosine x. And now this is closely related to one of our Pythagorean identities. Our identity says sine squared x plus cosine squared x equals 1. So if we rearrange that, move this over, we get 1 minus sine squared x equals cosine squared. So 1 minus sine squared we can rewrite as cosine squared x. And then we have cosine times cosine squared, so that becomes cosine 3 powers of cosine. And we're simplified. So that illustrates two of our simplification strategies, and maybe I'll stick those on a page over here. Leave some space below these. The first one, first strategy that we can use to try to simplify, whoops, I left out an I, is to factor. So oftentimes when you factor, you can do something. And the second one that we saw was to apply Pythagorean identities. And Pythagorean identities all have to do with trig functions squared. So with Pythagorean identities, look for trig functions squared. Often that will be very helpful. Right? Here's another one that will illustrate something. Say we have secant x sine squared x plus cosine x. What can we do with that? Well, that's a little bit less obvious. And this illustrates something, a go-to strategy. If there's nothing else that's obvious that you can do, and I'll put this somewhere down at the bottom, if all else fails, turn everything into sines and cosines. And we can always do that. Secant is 1 over cosine, so this becomes sine squared x over cosine x plus cosine x. Which brings us to another strategy. Anytime you have a fraction or multiple fractions, another strategy that you can look for, the thing that you can try is to make common denominators. That's a good way to simplify expressions a lot of times. So if we make common denominators, well, in cosine x we need to multiply by cosine x over cosine x. So that gives us cosine squared. Sine squared plus cosine squared, well, that's an identity we know. Sine squared plus cosine squared is 1. That leaves us with 1 over cosine x. And we don't like denominators, so we rewrite that as secant x. Here's another example. And sometimes, so you want to simplify. Sometimes there are multiple, well, always, there are multiple different ways to figure these out. But a strategy that you can use, and this applies whether it's one fraction or two or whatever, but a strategy that you can use is to make your denominator into a monomial. And how do we do that? Well, this is kind of like, when we have imaginaries, and side note, you don't need to write this down, but like if you had 3 over 4 minus I, right? Well, we multiplied by a conjugate to get rid of that, right? And the conjugate makes our denominator equal to 4 minus I squared. Well, this isn't precisely what's going on here, but if we make this into, if we do this, our denominator becomes 1 minus cosine squared. And 1 minus cosine squared is equal to sine squared. So if we have a particular denominator, then something we can do is make denominators monomial. We can make them one term sometimes by multiplying by and I put it in quotes, conjugate. It's like a conjugate for imaginaries, but it's not quite the same thing. So I put it in quotes. Yeah, that's another way that we can simplify things. And when we do that, then maybe I shouldn't, just for clarity, I'll write it on a separate line. Well, then our numerator, we have sine theta, 1 minus cosine theta. Our denominator is sine squared theta. Well, we notice we've got a sign in the numerator already. Oh, sorry, I'm off the screen. We've got a sign in the numerator already. So those cancel out, one factor of sine. Then in the numerator, we're left with 1 minus cosine theta over sine theta plus cosine theta over sine theta. We have a common denominator now. So we have 1 minus cosine theta plus cosine theta. The cosine thetas go away. So in the numerator, we're just left with 1. Denominator, we have sine theta. So that is then cosecant of theta. Yeah. So those are all different strategies that we can use. We can let's illustrate various strategies. We can factor. We can apply the Pythagorean theorem, make common denominators, make denominators into monomial, and then left too much space. But if all else fails, turn everything into sine and cosine. Always try something. See if you can figure it out. Right. There are a couple of questions on your homework that ask you to do some things that tell you to factor something like this. Well, in this, we'll factor just like a quadratic because we've got sine squared, nothing. So you can factor this like a quadratic. That's sine y minus 3, sine y minus 2. So then it's factored. This is something we'll use when we're solving trigonometric equations before too long. There's some like that. And some that are like that in disguise. Like we could have something like this. And we can't factor that right away because we have a cosecant and a cotangent. But we can apply an identity. Cosecant squared is equal to 1 plus cotangent squared. And then we have, then we have a quadratic type thing. 1 minus 3 gets us minus 2. And then we can factor it. Cotangent x minus 2, cotangent x plus 1, and it's factored. So sometimes you might have to apply an identity before you can factor. Dealing with the conjugate, there are also a question or two on your homework that say questions that say like this, something like this, rewrite, sine x over 1 plus cosine x, so it is not in fractional form. And the way we deal with that is just by multiplying by the sort of conjugate, like I said. We multiply by 1 minus cosine x. well, then we have sine x times 1 minus cosine x. And then in the denominator, we have 1 minus cosine squared x and 1 minus cosine squared x becomes sine squared x. And then a factor of sine cancels out. And if we want to pull everything out of the numerator, a sine, well, we could distribute, actually, a sine in the denominator. Yeah, we could distribute that. Makes it 1 over sine x minus cosine x over sine x. So then we can write that as cosecant x minus cotangent x, and now it's no longer a fraction, so that's a little bit better than what we had before. A couple other ways we could, one other way we could put this together is to do log stuff. Combine log stuff, say we have natural log of cotangent theta plus natural log of secant theta. Say we want to rewrite them as 1 log and simplify. Well, that's applying a log property that we learned last semester and combining it with what's going on when we add the logs. It's the same as multiplying what's inside the logs. And if we turn everything into sine and cosine, let's see what happens here. Cotangent is cosine over sine. Secant is 1 over cosine. So cosines go away, leaving us with 1 over sine, and 1 over sine is cosecant theta. So we're left with natural log of cosecant theta. So that's combining log property with our trig identity stuff. The last thing is just an exercise in algebra with trigonometry. There are a problem or two that says something like, use the substitution x equals 3 tangent theta to rewrite square root of 9 plus x squared. Right. And all they're asking you to do is plug it in. So x equals 3 tangent theta. So plug in 3 tangent theta. And you notice when you do so, 3 squared is 9, and tangent squared. And you can factor out a 9. And 1 plus tangent squared is secant squared. So then we can take the square root. Square root of 9, of course, is 3. Square root of secant squared is secant. Actually, the square root of something squared is absolute value. So that would be 3 times absolute value of secant theta. So again, just to conclude, always try something. We have a list of strategies that I gave you somewhere. We have this list of strategies we can try, but what's especially important is that you do try something and keep on trying. Persevere, and you'll find that you learn more that way, and you'll be able to do more the next time.